Notice here we have 4 terms to work with. So the first step is to break the polynomial into 2 groups. From there, we'll use our greatest common factor technique on the first group, and then we'll use greatest common factor on the second half or second group. Step 4, we should notice a common factor in the binomial portion. And once we do that, we'll be able to factor out that greatest common factor to completely factor the polynomial. So in order to break this into 2 groups, I'm just underlining the groups. Never use parentheses because that takes on a whole new meaning. So group 1, we notice that both terms have some x. We're comparing 3 with 2. 2 is smaller, so x squared is the greatest common factor. Now use the distributive property to recreate those 2 terms. X squared times x matches x cubed. X squared times something needs to match positive 4x squared. Well, notice x squared is already accounted for, but that plus 4 is not. So positive 4 is needed. Start over again with the second group. So we've got a positive 3x plus 12. This time we have a numerical coefficient in common, and that would be positive 3. So to recreate those terms, 3 times x would match positive 3x, and 3 times positive 4 would match positive 12. So notice I didn't just write a 3 in this gap, I put the plus sign with it, and that is crucial. If you don't include the plus, then you're just ending up with one long string of multiplication, which is not correct. So be sure to include any plus or minus that is required. How do you know if you should use plus or minus? Well, when you are distributing, that's when you'll know. Positive 3 times positive x is the only way to get positive 3x. So that's how I knew to use a plus sign there. Now do you notice that in these quantities we have an exact amount? So do you notice in these quantities they are exactly the same? That is your common factor of x plus 4. So to get the other factor, you are joining x squared with positive 3. And this is the completely factored answer. You can check your answer by multiplying these binomials. So if I distribute x times x squared, I would get x cubed. X times positive 3, I would get plus 3x. And then I could distribute 4 times x squared to get positive 4x squared, and last 4 times 3 to get 12. These 4 terms should match what I started with. X cubed was the first term, and here it is. Positive 4x squared was next. Here it is. Positive 3x, we have that, and our last term of 12 is also accounted for. Again, the order that these appear doesn't matter as long as we have created them all. So we have a few more examples to practice the grouping technique. So basically what we're doing is taking this grouping process, which breaks the polynomial into 2 smaller groups so that we can use our greatest common factor technique. So first, break it into groups. In the first group, we have coefficients of 6 and 10. Those are even numbers, so it looks like 2 is what both of those numbers have in common. Also, both terms have x, so 2x is the common factor, and then we distribute to figure out what is missing. 2x multiplied by 3y would match 6xy. And then 2x times 5 would match the 10x. Now what we learned from the last example, let's go back and look, we noticed that the amounts in the quantity were exactly the same, and they should be exactly the same factor every time you use the grouping technique. So we could use that as a hint. When I factor 9y plus 15, I should end up with a quantity of 3y plus 5. So all we have to do is fill in this gap with the common factor. So when I multiply 3y times something, I need to match 9y. So it looks like positive 3 was the missing factor. Does it work with 5 times 3? It does make positive 15. So plus 3 is needed to fill in that gap. Notice how we have a common factor now of the quantity 3y plus 5. And to complete the factoring, you simply are taking this 2x and plus 3 and joining them to make the other factor. So our completely factored answer is the quantity of 3y plus 5 times the quantity of 2x plus 3. For example 3, we'll notice we have 4 different terms. So I'm just taking the first 2 as a group and the last 2 as a group, and then I can use the greatest common factor technique. I've got coefficients of 16 and 8, so those are both divisible by 8, and it looks like a is a variable common factor. 8a multiplied by 2b would recreate that first term. And 8a looks like a match, however there is minus here, so negative 1 this time is the placeholder. Leave yourself a little gap there, and in the quantity we know that 2b minus 1 should appear. So working backwards to fill in that gap, 2b is multiplied by something to match negative 6b. So we need minus 3. So now you can see sometimes we use a plus, sometimes we need to use minus to fill in the factor. And check your last term. Is negative 1 times negative 3 a match for plus 3? That looks great. So notice how we created a common factor of 2b minus 1. And the other factor comes from joining 8a and negative 3. So 8a minus 3. We have completely factored our